Good morning, students. As this welcomes you all. Now we are ready with our new topic. That one is Kirchhoff rule. Let us talk about the Kirchhoff rule. What are the Kirchhoff rules? The first one rule is junction rule, and second one is called loop rule. Junction is what? Junction is a place where all the something just are coming to meet. That is here what junction represents. That this rule states that the algebraic sum of all the current meeting at a point, the algebraic sum of all the current meeting at a point remains 0. That means sigma I is equal to 0. What this rule says that? This rule says that all the algebraic sum of all the current meeting at a point or a junction is always equal to 0. And this one, second one rule is that loop rule. It is about voltage. It is said that the algebraic sum of all the potential difference or the algebraic sum of all the voltages, whether it is EMF and the potential difference, is always equal to 0. That is E plus sigma delta V is equal to 0. So these are the two rules which are given by Kirchhoff, and these are used to very useful for an electrical circuit. The first one is junction rule and second one is loop rule. First one is junction rule is very important for you all. What is junction rule? The algebraic sum of all the current meeting at a point is always equal to 0. And the second one is loop rule. Loop rule is about potential difference. The algebraic sum of all the potential difference, that is, you can say that potential difference and the voltage or the EMF is always equal to 0. So moving further, we are having one of the important topic, that Wheatstone bridge. Wheatstone bridge is what? Wheatstone bridge is a device which are having three of the known resistance to find out one unknown resistance. How? It is given like P by Q is equal to R by S. If I am just making it like a bridge, suppose there is a key, there is a galvanometer, there I am just forming it. This one is P, Q, R, S. This can be, the I current can be flown here. There would be I1, there would be I2, there would be IG, there would be I1 minus IG, there would be IG plus I2 or I2 plus IG, again there would be I. So this is the circuit of Wheatstone bridge. It is basically works for to find out the unknown resistance. If three resistance are given, we can easily find out the fourth one resistance. So this is all about Wheatstone bridge. What is that? If we are given P, Q, R, then we can easily find out the value of S. So this is a device which is used to find out, or it is a bridge type of structure. That is why it is called Wheatstone bridge, which is used to find out unknown resistance when three of the resistance are given to a circuit. So this is Wheatstone bridge. Moving further, very rapidly we are talking about the next topic. That one is meter bridge. What do you mean by meter bridge and why it is called meter bridge? It is also bridge type of structure, which is like you must have seen in your lab. If you have visited your lab, you must have seen there is a type of a structure which is based on the Wheatstone bridge. It also works on the Wheatstone bridge, and there is a wire of 1 meter, or you can say that 100 centimeter. 100 centimeter and 1 meter. This device looks like this, and here by using this device, if one of the known resistance are there, then we can easily find out a known resistance or a specific resistance of a wire. If suppose this one is R, which is known, and here the another one is X, then we can easily find out the value of X. Here one of the device which is attached, that is called galvanometer, and there would be a jockey. Remember this always, where the jockey shows, where the galvanometer shows null point. What do you mean by null point? Let me discuss with you what is null point. Null point is what? Whenever you are just connecting this circuit, like battery positive and negative end of the battery goes to the key, and there would be a rheostat. If you know these all points and you are just connecting the circuit like this, then you will be getting that if you just touch this jockey, and if you are just touching this wire, this 100 centimeter wire, and this galvanometer shows zero deflection. Galvanometer is a device which is used to detect the direction of the current. So where the direction of the current becomes zero, or you can say that it is like this one, and it is showing zero deflection. It is showing what? Zero deflection. That particular point is said to be what? Null point. And here, if the jockey is being attached with this length, then this length can be considered as L, and the next one would be 100 minus L. So if you are to find out that value of X by using this device, we can find out the value of unknown resistance if one of the known resistance are given. Is given. Like the formula can be written like R is directly proportional to L. That is R is equal to KL. Moving to the next one, that X would be directly proportional to the appropriate length. That is X is directly proportional to 100 minus L. This one can be X is equal to K 100 minus L. If we are just dividing these two, then we are getting what? R by X is equal to KL upon K 100 minus L. By using this relation, we can easily find out the value of X, that is R, K cancelled out, R 100 minus L upon L. So this one is unknown resistance. By using this, we can find out the value of unknown resistance, that is X. And by using this formula, we can also find out the specific resistance of a given wire. If one of the wire is given, then we can easily find out that specific resistance of the wire. So this one is all about meter bridge. It is based on the Wheatstone bridge because it is also in form of P by Q is equal to R by S, as it is shown here. As it is shown that R by X is equal to 100 upon L upon 100 minus L. The next one topic is potentiometer. Potentiometer is a device which is used to find out the EMF of a wire when no current is drawn from the wire. Remember this one is very important. Now, we are just going to study about the potentiometer. Potentiometer is what? Potentiometer is a device which is used to find the EMF of a given primary cell without drawing any current from the cell. What I'm saying potentiometer is a device which is used to find the EMF of a given cell without drawing any current from the cell. And it is just based on the principle that potential difference on any part of the wire is directly proportional to that length of that wire. How? It is used to find out, it is used for two basic purposes, that is to compare the EMF of two given primary cell, and the next one is that to find the internal resistance of the cell. The circuit of this potentiometer is made up in a very critical manner, but you need not to worry about that. You have to just make the circuit. It has turned wire. It has turned wire of many layers, like I'm making it. It has a two frame that said as A and B. When we are using to find out to compare the EMF of two given primary cell, then we have to attach this particular point with the positive end of the battery, and the negative end of the battery would be attached with that what? A key, and there would be a rheostat. Very simple circuit, I am telling you. And this A point should be attached with two of the cells. One is Daniel cell we are taking, and another is we are taking that what? Lagrange cell. And these cells, the other end of these cells are attached with the two-way key. You must be learning that what is two-way key. This should be attached to two-way key, and this mid part would be attached with the galvanometer, and this would be attached to the jockey. Again, we are only having one work, that by using this jockey, we have to find out the null point. If we are getting that null point, then that particular EMF E1 would be directly proportional to L1. As I was telling you about that principle of potentiometer, then what is the principle of potentiometer? That means what? The potential difference across any part of uniform wire is directly proportional to the length of that particular portion. So here what I am telling you, E1 is directly proportional to L1. If suppose I am using Daniell cell and then we are getting that E1, then it can be written like E1 is equal to KL1. Moving further, again we have stopped using that Daniell cell. Now we are using Lagrange cell. Then we are just finding out that E2 is directly proportional to L2. That can be written like E2 is equal to KL2. Then what would be there? By dividing equation 1 and 2, what we are getting, E1 upon E2 is equal to KL1 upon KL2. K cancel out, that E1 upon E2 is equal to what? L1 upon L2. By using this, we can just compare the EMF of two given primary cell. And here, to find the internal resistance of the cell, we have to use only one of the cell, and the second one would be resistance box. What would be using? Resistance box. The whole circuit would be same. We'll use resistance box in place of another cell, another primary cell, and we can easily find out that V is equal to E minus IR. We know this formula, V is equal to E minus IR. By using this formula, we can just find out that relation IR would be equal to what? E, if we are dividing it by V, then E upon V minus 1, it would be written like IR upon I capital R. Here small r is said to be what? Internal resistance. Here small r is said to be internal resistance. So here we can find out that R by R is equal to E upon V minus 1. This one would be R, E upon V minus 1. How will you find out that value of E upon V? E upon V. E is what? E is the EMF of a primary cell and V is potential difference of resistance box. E is what? E is the EMF of primary cell and V is the potential difference of resistance box. So E would be directly proportional to L1 and V would be directly proportional to L2. By using galvanometer, we can find out as we were finding out here. Similarly, we will be finding out here. So E1 is directly proportional to L1. That can be written like E1 is equal to KL1. Likewise, V2 can be written like KL2. If I am writing it here, then we can easily find out E by V, that is L1 upon L2. We can put the value, that is R, L1 upon L2 minus 1. We have to find out that internal resistance of the primary cell. By using this particular method, we can just solve out that potentiometer. This is all about for this chapter, current electricity. I hope you are getting this point. This one was just a glimpse of the chapter that we have seen. Many of the topics comes in this chapter. We have to read that very carefully and we have to apply for the particular application of the topic. So I hope you are getting these points. As this, will see you again in next lecture. Thank you.